Hey everyone, and welcome to this explainer. Today, we are absolutely decoding dyslexia. We're looking at the brain, the struggle, and the advantage. If you want to get past all those superficial myths and really understand the actual neuroscience, the psychology, and the fascinating evolutionary history behind how our brains process language, well, you are in the exact right place. We're going to completely decode what is literally happening inside the head, why the struggle is so incredibly real, and ultimately, why this cognitive variation might actually be a profound advantage.
Okay, let's dive into this because I want to start by subverting almost everything you probably think you know about this condition. When most people hear the word dyslexia, they immediately picture a very specific and highly inaccurate scenario. They picture this, right?
Mixing up letters. Well, actually, scratch that. We need to completely tear down this massive surface-level oversimplification right out of the gate. Dyslexia is fundamentally a language processing difference in the brain. Yes, for sure, the visible problem, the output that we actually see, is a struggle with reading. But the hidden truth, the actual biological mechanism, lies much, much deeper. It's all about how the brain represents, stores, retrieves, and manipulates language itself. And this brilliantly illustrates why this happens. Just look at this timeline. For 99.99% of human history, we did not read. We just spoke and we listened. Writing really only just emerged in Mesopotamia around 3200 BCE, then Egypt, then the Indus Valley. In evolutionary terms, that was literally just a few seconds ago. So evolution simply has not had enough time to develop a dedicated reading organ anywhere in the human brain. Think about it like this. You have roughly 86 billion neurons firing in your head right now, all connected by hundreds of trillions of synapses. Yet, not a single one of those 86 billion neurons evolved specifically for reading. Because we don't have a natural reading center, the brain has to improvise. Reading is, essentially, an evolutionary biological hack. So to pull off this hack, the brain forces three completely different pre-existing systems to somehow work together. First up, System 1, visual recognition in the occipital cortex. This identifies shapes like A, B, C, D. Then, System 2, sound processing steps in to convert those visual letters into sounds, a process we call decoding. And finally, System 3, meaning processing, searches through your language networks to figure out what those combined sounds actually mean in context. Dyslexia is simply a totally natural variation in how this improvised, hacked-together network develops and connects. Now, what's really interesting about this slide is the sheer difference in mechanical effort we're looking at here. For a typical reader, this three-part network fires so incredibly fast that they see the word cat and bam, they instantly, automatically recognize it. But in a dyslexic brain, that reading network develops differently. They might have to consciously look at C, then A, then T, and laboriously string them together. Now, the difference for a single word might seem small, but multiply that conscious, exhausting effort across millions of words in a textbook, the barrier becomes absolutely enormous. Which brings us to the single most important concept in understanding dyslexia's mechanics: phonological awareness. This is your ability to separate, blend, and map sounds to letters. Like if I ask you to remove the C from cat, you effortlessly get AT. But if your brain naturally struggles to isolate and manipulate those individual sounds, the very foundation of reading becomes incredibly unstable from day one. On top of that, we absolutely have to consider working memory. This acts exactly like RAM in a computer. It's your brain's temporary storage system. Imagine trying to read a long, complex sentence. You have to actively remember the words at the beginning of the sentence while simultaneously decoding the new words at the end. If decoding takes up all your mental energy, your working memory gets entirely overloaded, and comprehension just drops off a cliff. And because the brain's language and memory networks are so deeply interconnected, dyslexia isn't just one single reading issue. It actually comes in multiple varieties. You've got phonological dyslexia, surface dyslexia, rapid naming deficits, and severe double deficits. But it also bleeds into totally different areas of life. Many people with dyslexia experience huge organizational difficulties, severe left versus right direction confusion, trouble estimating time, and major struggles with note-taking, simply because processing spoken and written information at the same time completely overloads the system. It affects the whole shebang. So, what does this all mean? Where does this biological difference actually come from? Well, the genetics revolution has given us a really clear answer: heredity. Studies on twins and families show that the heritability of dyslexia ranges from 40% to 80%. That is huge. It means genes explain a massive portion of the risk. During fetal development, billions of neurons migrate to precise locations in the brain to form those language networks we talked about. Tiny natural genetic variations in how those neurons migrate and connect directly influence language processing later in life.
Let's move to and see how this builds into our everyday lives, directly impacting our classrooms and workplaces. Globally, the prevalence of dyslexia is estimated to be somewhere between 5 and 15%. To put that into perspective for you, in a typical classroom of 40 students, 2 to 6 of those kids likely have dyslexia. It is incredibly common. Yet, so many remain completely undiagnosed, just silently struggling with a biological variation they don't even understand. And here is a totally fascinating twist. The environment, specifically the language you happen to speak, acts as a massive magnifier. English is notoriously complex and non-phonetic. Just look at the words though, through, and tough. Exact same letters, entirely different pronunciations. No way around it, this complexity severely magnifies the dyslexic struggle. However, in highly phonetic languages like Italian or Hindi, where letters actually reliably map to specific sounds, reading is generally much easier, and dyslexic individuals often perform significantly better than they ever would in English.
But, regardless of the language being spoken, the emotional toll of an unsupportive environment is just completely devastating. Imagine a child being forced into a system that demands rapid reading, right? But their brain literally processes language differently. What happens is they experience this repeated, daily failure. And tragically, they often draw this incredibly heartbreaking conclusion: I am stupid. It's awful. And that belief, it can persist for decades, leaving lifelong psychological scars that honestly are often so much harder to overcome than the reading difficulty itself. This directly leads to some very severe secondary mental health risks. We see incredibly high rates of anxiety, depression, chronic academic stress, school avoidance, and rock-bottom self-esteem. But it is absolutely crucial to understand that dyslexia does not biologically cause anxiety or depression. Not at all. These are the secondary scars of a systemic lack of support. They are the direct result of a society that incorrectly equates rapid reading with intelligence. But hey, there is incredible hope here, rooted in one of the absolute most important discoveries in modern neuroscience: neuroplasticity. The brain changes through experience. Whether a person is 7 or 70 years old, the brain remains plastic. Through evidence-based structured literacy, explicit phonics, and a lot of repetition, neural pathways can literally be strengthened and rewired. MRI studies actually show measurable physical changes in the brain's reading networks after targeted intervention. It is quite literally never too late to rewire the hack.
So, the crucial point is the dyslexic advantage hypothesis.
Science clearly shows us that the correlation between intelligence and reading ability is surprisingly weak. You can read poorly and still think brilliantly. In fact, human groups survive and thrive precisely because of cognitive diversity. While some brains specialize in fine detail processing, the dyslexic brain often develops incredible alternative thinking strategies. We frequently see immense, out-of-the-box strengths in areas requiring big-picture exploration and pattern detection. This is exactly why people with dyslexia heavily over-index and absolutely excel in fields like entrepreneurship, engineering, architecture, design, high-level leadership, strategic planning, and the creative arts. You can actually see these alternative thinking strategies heavily represented among some highly successful individuals. Figures like Steven Spielberg, Tom Cruise, Richard Branson, Keira Knightley, and Pablo Picasso have all been associated with dyslexia. Now, we definitely don't highlight these names to claim that dyslexia magically creates genius, not at all. We highlight them to prove that when this cognitive variation is supported rather than shamed, it allows people to navigate the world and solve complex problems in highly innovative, deeply valuable ways. If you take away just one single thing from this explainer, please let it be this: dyslexia is not a defect. It is not a disease. It is simply a biologically influenced difference in how the brain develops and processes language. Does it present real challenges in a text-heavy world? Yes, for sure. But when paired with early identification, evidence-based instruction, and a truly supportive environment, individuals with dyslexia can achieve absolutely incredible success. We have got to respect and nurture this neurodiversity. We are standing right on the edge of a totally new frontier. Scientists are already exploring AI-based early detection that could diagnose children years before they ever have to experience the pain of failing a reading test, right alongside personalized interventions that maximize that neuroplasticity we talked about. So I leave you with this provocative thought. With these rapid advancements in our hands today, How will we change our schools, our workplaces, and our own mindsets to finally empower the next generation of dyslexic minds? Think about that, and I'll catch you in the next explainer.